Alright, hello, in this semester course, I'm going to go quickly over some of the highlights of Calculus Semester 1 review packet. First one is a related rates. You're given an equation, differentiate with respect to t. You'll have this differential equation, and now what you can do is plug in everything you know, solve for what you don't. On the second one, use a calculator to do a derivative. Well, that's math 8, and you just set it up like it is here, ln of x. Good, close that one, and then times it by cosine of e to the x, and you want to make sure you close that one too, and then you put in the 3 there, and that's what it's going to do. It's going to take the derivative of this function and then plug in the number 3, and there you go. So just be careful on your calculator that you type it in carefully, and you have your calculator in radians. Number 3 is a mean value theorem problem. Well, that means the derivative, which is here, is equal to the slope. So you have to do y2 minus y1 over x1 minus, or x2 minus x1. Regular slope, and that's what we did up here, set it equal to the derivative. The limit 3 from the negative side, so numbers that are smaller than 3. So I'm just using that equation. I don't have to check both of them, because I'm just doing numbers that are less than 3, and that falls to that one. Optimization, write an initial equation, primary equation, secondary equation, get it down to 1, set the derivative equal to 0. Don't forget to test to make sure it is a maximum. Same thing here, max equation, 2 variables, use this to knock it down to 1 variable. The derivative here, well, it's best to rewrite this. I always rewrite it like over here. And then I can do the power rule once, and then we do chain rule twice because we have derivative of sine of 2x is cosine 2x. Don't forget there's a chain rule twice on this one because we have to take the chain rule of that. Limits with rational symbols, multiply by the conjugate. Even if it's on the numerator, multiply it by it, it'll fix it. Number 10, just some limits left and right. Number 11, horizontal asymptotes. Again, you plug in these here, end behavior. If it's going to infinity, that's a horizontal asymptote. And what we can do here is just simplify this. And if we simplify this, we turn it into this. Make sure sometimes it's not simplified for you, so you got to simplify it. And then if I just do what's significant, I have 2x squared over 2x cubed. That divides out, and that leaves 1 over x. And 1 over infinity goes to 0. Classic problem here, farmer with a rectangular field, 3 sides, x and y. Again, here's the max equation. There's the secondary. Get it down to 1. Set the derivative equal to 0. On number 13, we have a piecewise function. You have 3 different parts here. You have numbers from 0 to 4, 4 greater than 4 to answer the questions. Average rate of change is slope from algebra class, y2 minus y1 over x2 minus x1. Your algebra teachers could have called it average rate of change. Same thing as slope. Functions, take a look at each part. Answer that. Number 16, is it continuous? Well, that means you have to plug in this value here of 2 and see what happens. What happens on this side? Where does this go? And it goes somewhere. If I was doing a graph, it goes somewhere, and then the question is, does the other graph start at the same spot? This graph ends, where does this one start? And they should be at the same spot for continuous. Number 17, everything but 1. I mean, you could have wrote it like this. I know sometimes when in class we write it like this. That's everything but -1. At what x values within the domain is the slope of f approximately 0? Well, that's where the slope is 0. And on these ones, this should have said the graph of f. Where is the slope of the line 0? Well, here it's 0, here it's 0, here it's 0. This should have been the graph of just the function. The limit here, if you graph this, you'll see it goes to 0, or you could just work your way through it, saying this bottom's going to get bigger to infinity, and the highest the top is going to go to 1. In behavior, again, is this max equation here. The derivative quotient rule, low d high minus high d low. Critical points are when the derivative is equal to 0, and then you can do the derivative test. On this one here, we have a function, and then we differentiate it with respect to t. It should have been dt there. And they give you the x value to plug in, but they don't give you the y value. So you could just go ahead and plug this in here to figure out that y is 4, right? If I put a 3 here, that's 9. 25 minus 9 is 16. The square root of 16 is 4. It could have been plus or minus 4 on this one, but we just did 4. The limit here is 3/2 because those would factor out and be gone. Horizontal tangents are like these up here, where the slope is equal to 0 of the derivative. Derivative here, 3 cosine, plug in that value, use your unit circle. The limit here, can't plug in 1, so I factor it out to the point I can plug in 1. The derivative here, make sure you know the derivatives of these functions. I'm going to do one right now here. The derivative of this, if this was by itself, remember these problems are 3-step problems. First we leave it alone, and then we tack on the natural log of the base, and then we tack on the derivative. So that's what that derivative is right there. This part of it, and you see it right there, is 1, 2, 3. And it works just like this. Let's say I had log base 5 of 6x. This is also a 3-step problem. Step 1 is to put 1 over itself. We leave it alone. Left alone, but it's in the denominator because they're reciprocals. And now I tack on natural log of the 5. Same thing here, but it's reciprocal. And the last thing is the chain rule. And in the case of the chain rule isn't in the denominator. The chain rule is just by itself. So that's 1, 2, 3 parts. And then these would simplify here. So we would just have 1 over x ln of 5. But these log and exponentials, they're reciprocals of each other. They are inverses of each other. Think of it that way. Leave it the same, natural log and chain rule. Number 30. We have a function. What's the height when the velocity is 0? We'll just take the derivative, plug in 0, solve for t. Instantaneous rate of change always means find the derivative, plug in the value. Here we go, another related rates problem. We have this, and then we take the derivative of both sides. And the limit here, you could graph this on your calculator. You could just do some thinking that if I came to -2 from a little bit on the left of it, I'd have this number here, and I'd have an infinitely smaller negative number. So let's get smaller and smaller and smaller and smaller. 1 divided something really small is going to be really large. It's negative infinity. Derivatives here, some basic derivatives. Got to use the power rule or product rule there. Tangent lines means find the derivative, plug it in. We have a -4 for a slope. -4 goes there, and then you plug in your point. You can figure out b. You can put the slope with the b value and have a line. Where do you get the point? Well, you get the point from this initial equation. Instantaneous rate of change. Take the derivative, plug in r. This is when you have different rates changing, you have to do, down here. When you have the instantaneous rate of change, you simply have to take the derivative, plug in 4. That's all it's asking. It's saying how is the volume changing at that one particular point. All right, hope this helps. I have videos for the rest of them too.